Good afternoon. Am I audible? Anyone please confirm? Yes? Please let me know whether I am audible or not. Okay. Thank you. So we are going to start today's lecture, the problems on diode. Now, before discussing the problems, just let me discuss very few concepts on diodes. Okay, very briefly I will be discussing. So I will start right now straight away. I hope others will join. Good. Right. So diode, you understand that diode is semiconductor device. We have one junction. So this is one semiconductor, this is one junction. One side is P type, other side is N type. And the symbol we'll use for this PN diode is like this. This is your P side and this is your N side. And this PN diode is used to get unidirectional current, means current. This diode will allow to flow the current from P to N side only. So this side current is allowed, but opposite side current, this current is not allowed at all. The meaning is that if I connect this diode with proper supply voltage, this P is connected to positive terminal and N is connected to negative terminal, and we can have one current limiting resistance R. That time current will flow through this diode and this voltage is V, right? This configuration is called forward biased configuration and current will flow, diode is on. But if you consider reverse way, the diode is connected in opposite terminal, this is negative, this is positive. That time this current is 0 ampere. Diode will not allow to flow the current in opposite direction. This direction current is not allowed at all. Okay. Now how to measure the current, how to calculate the current? That is one important concept, important thing, because then only we will be able to solve the problem related to diodes. So actually the diode, this PN diode, this VD-ID characteristics, if its voltage is VD and the current is ID, right? We have one equation that ID equals to IS, reverse saturation current, times e to the power VD upon eta VT. VT is thermal voltage minus 1, right? That you know for perhaps. So what is the figure for that? So we have this kind of figure. If this is your VD, this side if I plot ID, so this is one exponential rise, right hand side, and left hand side it is decreasing. This is one continuous curve, exponential curve, and that equation I have said it is IS times e to the power VD upon eta VT minus 1. Now this kind of equation is very hard to consider because if I use this kind of equation in a circuit, then we can't solve for this ID or VD easily. Okay, so that's how we'll consider one simplified model. Okay, and left hand side, I should mention this thing that beyond certain negative voltage there is a breakdown, and that breakdown voltage is called Zener breakdown voltage, VZ. So in this lecture we will not discuss about Zener breakdown, rather we will consider about the forward biased and reverse biased. And for Zener breakdown voltage or Zener diode related problem, that already I have solved in other videos. So if you have certain, if you want to follow those things, it is already available, you can go through. Okay. Now here we will discuss few more problems, interesting problems from GATE papers. So to solve those problems, what we will do? We will take very simplified model. Okay. What are the models? So one model is that it is for ideal diode. In ideal diode, what is happening? I will consider this side is VD and this side is ID. Now when diode is forward biased, then you will get huge current, but that time potential drop across the diode is 0 volt only, and reverse biased the current is perfectly 0. So this is the ideal diode VD-ID characteristics. What is implies? When diode is on, that time the VD equals to 0 and current is non-zero. ID is positive, something positive. Okay, that you should make sure. ID means from P to N side current. Okay, that current is positive, nothing else. Right? So this is the VD-ID plot for ideal one, and for practical one we can consider this kind of thing, that VD, what I will do for practical, just 1 minute, for practical diode we are going for like this. This is your VD, this side is ID, right? And we'll assume that when diode is on, then there is a constant voltage drop. Okay, that voltage drop will be here. This is your VD, and less than that it is perfectly 0. So this voltage is 0.7 volt per silicon diode. So what is the meaning? When VD is more than, input voltage is more than 0.7 volt, then only diode is on, otherwise diode is off. This is only for silicon diode, and for germanium diode this value is 0.3 volt. Okay, so for silicon diode it is 0.7 volt we will compare. For germanium diode we will consider around 0.3 volt. If nothing is mentioned in the problem, you will assume that it is made of, diode is made of silicon diode. Okay, clear? Now we will start solving the problems on diode. Okay, let us consider the first problem. So do you have any question? Anybody? It's a very simple thing I have discussed, nothing. So I think everybody knows about this one. You know these things, but yet this is much useful one. Okay, so this is the first problem. Can you solve this one? Okay. Now in the circuit you can see that you have one diode that is connected across 2 kilo ohm resistance, and another resistance is connected in series, that is your 6 kilo ohm. Is it okay? Now question is, how to find out the current I2. So this current I2 we need to find out, right? So what is the main challenge here? Main challenge is that we need to understand whether diode is on or not. That is the first task. If you want to solve any problem related to diode, then first you think about whether the diode is on or not. If diode is on, then the potential across the diode is 0.7 volt, it is given. Okay, then easily we can find out the current. Now, what is the strategy to solve this kind of problem? First, you can assume that this diode is on, then solve the problem. And later on, what you will do, you will find out the diode current. I have said that if this is the diode, practical diode, so when it is on condition, it could be replaced by one potential drop, and that potential is only 0.7 volt. That is fine, but we need to find out the current flowing through this diode is ID, and that is positive from P to N. That you have to make sure, right? So with the assumption that diode is on, find the current ID, and if the ID is really flowing from P to N, then your assumption is correct. You will continue with that assumption, you will get the correct answer. Otherwise, you should revise this thing because your assumption is wrong if diode is current is from N to P. I hope you have got this point. First, assume that diode is on and replace the diode by constant voltage source 0.7 volt and calculate the currents, all the currents including diode current. And then diode current, if diode current is positive, means from P to N, your assumption is correct. Otherwise, your assumption is wrong, diode is off. Then again, you should resolve the problem considering diode is off. Okay. Now, here, can you solve? Can you tell me what is the, yes, you are saying that 0.21 milliampere. I think there is little issues. Why it is 0.21? Are you considering 2 upon 2 plus 6 means 2 upon 8? No, it is 2 upon 6 only you are considering. 1 upon 3. What is the current? All those things. How you have got this thing 0.21 milliampere? Okay, so let me solve this thing. So this is the resistance, it is 2K. This one is 2 volt, and this side I have one resistance, that value is 6K, and here I have one diode, right? So I assume that this diode is on. I am assuming this diode is on, means this potential is only 0.7 volt. If it is only 0.7 volt, then what is the current to this one? That is your I2, and this current is I1 suppose, and this current is ID. Okay, so can you calculate all the things with the diode on? So what is the I2? Anyone please, can you please let me know? This 2 volt minus 0.7, because 0.7 is a drop across this 2K or the diode. So yes, so this 2 minus 0.7 upon the 6, that is a milliampere. So it is 1.3 upon 6. So this is coming about 0.2, it is 10 means 1, and then it is 406 I can consider. Okay, so 0.216 here. So you have said that 0.21621 milliampere, that is the current if diode is on, right? The first, I hope you have assumed that diode is on, but is it really on? That is the question. We have to make sure the diode is really on. If diode is on, potential drop across the diode is 0.7 volt, and then you will get this 0.216 milliampere in 6 kilo ohm resistance, right? Now can you find out the current I1? Anyone please? Yes, yes, because so it's good to see because you are here. So this, what is I1? I1 is simply the current through the 2 kilo ohm resistance. So this is your 0.7 volt is a drop, and upon 2, that is milliampere, this value will be 0.35 milliampere. So I1 is 0.35 milliampere, this current is 35 milliampere, and you can see this current, and this current is again I2. So this current is coming here. So this 2 volts supply voltage will, this voltage will supply I2 current, total current, loop current is I2 only, and I2 is 0.216 milliampere, and out of this, so this side current is 0.35 milliampere. So what is ID? ID is simply this I2 minus I1. Okay, so in this case 0.216 minus 0.35, and that is negative, right? So if ID is negative, we have assumed that it is on. With this assumption, we have calculated diode current, but eventually we can see that diode current is negative, means it is not consistent with our concept that when diode is on, the current will be, should be positive, means from P to N, but it is showing that its current is negative, means N to P. It is not allowed by the diode, means assumption is wrong. Diode cannot be on, so we can say that diode is off. And if diode is off, right, now we are confirmed that diode is off. So what is the current I2? We should recalculate the current. So if diode is off, then I2 is, so this is open circuit diode. So this 2K and 6K, they are now connected in series. Simply they are connected in series. Now can you tell me what is the current then? Current will be this 2 volt upon total resistance 2 plus 6, right, means 1 upon 8, that much milliampere. Is it correct? And that value will be 1 upon 4, means 0.25 milliampere. Is it fine to everybody? Good. So it is 0.25 milliampere, not 0.21 milliampere, considering it is on. Actually it is off. Then you will find this thing 2 upon, so students will make mistake here. Yes, if it is ideal one, obviously, if diode is ideal one, means the point this when it is on, its voltage is 0. Then with this configuration, always it will conduct. Okay, this is a problem because it is practical diode. Because you are correct, exactly correct. If diode is ideal one, then obviously diode will be on. And if diode is on, the voltage across this one is 0. So it is 2 upon 6, that will be the current. Okay, means 1/3, means 0.33 milliampere. Exactly, you are correct. Okay, I hope all of you are convinced. We can move forward. Now this is the next problem. So this problem appeared in GATE ECE 2012. Now I have considered practical diode, but this time they have given the model for the diode. Okay, now we need to understand what is this model. So they have very simple circuit. One very simple circuit is given, 10 volt source with series with 1 kilo ohm and 1 diode, and VDID characteristics or VI characteristics for the diode is given here. Okay, so this is the diode characteristics. What is that? This I equals to B minus 0.7 upon 500. Okay, when V is more than 0.7 volt. This implies if it is on condition. This is a condition for on. When diode is on, then current is also depending on the voltage. Okay, actual voltage across this diode. Earlier we assumed that any current can flow and voltage across the diode is only 0.7 volt, but this is not the case here. So what is the meaning of this? This implies that I can write this V equals to this 0.7, right, plus I into 500. Can I write in this way? So what is the curve? The curve is very simple. Left hand side it is as it is 0. So you can see that it is given 0 when V is less than 0.7 volt. Okay, so this is your 0.7 volt. This axis is your V and this is the current. So this equation shows that it is a straight line again. So, but what is straight line? That line is, I can consider that beyond 0.7 it is having one resistance. When when I is increasing, B is also this thing. When I equal to 0, it is 0.7, right? So it is actually like this. Are you convinced? So because you are saying that it is 6.2 milliampere, it looks good. So what is this? I can consider this 500 as a resistance RD, because this is the constant, this 0.7, and beyond that RD is multiplied and you will get B equals to 0.7 plus I into RD. So this is the potential, I into RD. So here RD equals to 500 ohm. So this implies that is having one resistance while it is on, and that resistance is not too little. Generally it is not too high. For this problem they have given 500, but in practice when diode is on, that time diode resistance is very low. It is about 10 to 30 ohms kind of things. Okay, but they have assumed here for the problem 500 ohm. Okay, that we need to consider. So what do you replace? We replace this diode by not only one voltage source 0.7 but along with one series resistance. This is our model and that resistance is RD. Here it is 0.7 volt. Okay, so can I solve it now? Can you solve it? So this circuit, this is 1 kilo ohm and this diode now I can replace. I'll assume that diode is on. Okay, I'll assume that diode is on, means more than 0.7 volt. It will appear across these things. So this is your 0.7 volt and it is having one resistance here. Okay, and so this value is given 500 ohm. We need to calculate the current here. So what is the question? The question was to find out the potential across this diode. Okay, that is the important thing. So first calculate, or the current, probably current they are asking for the current. It's very simple thing. So it is 10 volt, right? So total current, this current ID easily we can find now. This ID will be 10 minus 0.7 upon total resistance, and that will be 1.5 milliampere. So this I can write 0.5 kilo ohm. So 1K plus 0.5K is 1.5K. So you will get this thing. It is your 9.3. And this is 15. This is 10. So this is 3. It is 2. And it is 3.1. So it is 6.2 volt. Sorry, milliampere. Yes, all of you are correct. The answer is 6.2 milliampere. Okay. I hope you have got this point. It's fantastic. Okay. So can you solve the next problem? So I will be discussing some interesting problem. Okay, which are generally appearing in GATE exams. So this kind of problems will be good for semester purpose as well, if it's a good institute. Okay, so can you solve this one? I can make larger one little bit. Now in this circuit we have diode as well as capacitor. Whenever you are having this combination, the diode with capacitor, this kind of circuit is called clamper circuit. Okay, voltage level is shifted. So diode plus resistance, that kind of circuit is called clipper circuit. But diode with capacitor, that kind of circuit will be called clamper circuit. So here you need to understand how much voltage capacitor will store. Okay, and when it will when capacitor will charge up, and when diode will be on. Okay, those are few questions that we need to understand. So if I consider very basics one, okay, so I have one capacitor and one diode. Okay, and here we are having one sinusoidal voltage. Suppose it is Vp sin omega t. Vp is the magnitude, peak voltage of the sinusoidal. Okay, so when it is positive half, like this. So this is the input Vp sin omega t. So when diode will be on, so I am considering only one part, I am not considering second part, only this capacitor C and this diode D. So when for this positive half, what is happening? The diode will be on. Why? The current can flow this side. Very first positive cycle, okay, the current starts flowing. Are you convinced? So whenever I will give some positive voltage, diode current will be something downward, and that is allowed because current can go from P to N side. So this diode will allow that current, and when diode is allowing the current and diode resistance will be 0 if I consider ideal diode, in that case capacitor will charge up quickly. So time constant is 0, so it won't take any time to charge up. So whatever potential you will apply, you will get the voltage across the capacitor. This capacitor voltage Vc will be the same as input voltage. So how long it will continue? Up to the maximum voltage. So this voltage is your Vp. So capacitor voltage will charge up to peak voltage Vp. And when the voltage level will start flowing, means decreasing. Input voltage is now decreasing from the peak value Vc. That time here the potential. Suddenly what will happen? Capacitor will try to retain the charge Vc. So this potential here compared to this one, if I call it is V naught, suppose, so input voltage is Vp sin omega t, and this Vc is Vct will be subtracted, okay, and that is the available voltage across the diode, right? And Vc is nothing but Vp. I can replace here Vp because capacitor is charged up to Vp voltage potential, okay. And you can see that when t is more than t by 4, so this is your t by 4, no, this is your capital T. When t is more than t by 4, this value is negative because sin omega t is always less than equal to 1. And once this voltage across the diode is negative, diode will become off. And if diode is off, then there is no more charging or discharging, nothing is there, okay. So capacitor will retain the voltage. So that peak voltage will be stored in the capacitor C. So in the clamper circuit, you need to understand that how much potential will be stored in a capacitor. That is the peak potential when diode will be conducting, and diode will conduct for only 1/2, rather 0 to t by 4 only, not more than that. Every time it will be off, this time it will be off, okay. Are you convinced with this concept? So the capacitor will charge up to the peak potential, peak voltage Vp by the time 0 to t by 4. That's all. And beyond that, capacitor will retain the charge, diode will remain off, okay. So the output voltage will be this Vp sin omega t minus Vp. This is your output voltage, okay. And I think this is the only question it is given here. So what is the potential across Vt? This Vt, okay. I have not added the next half. Now the concept is that, so what is the meaning? What I have said, this clamper circuit, this circuit will contain one capacitor along with one diode, So this is your capacitor and this is your diode, and if this potential, this is your Vp sin omega t, so this voltage will be stored Vp only, so this potential is V naught, and that will be simply, so that is always open, remain off forever. Okay, so but capacitor will retain the charge, that's how its potential will remain Vp. So output voltage will be input voltage Vp sin omega t minus capacitor voltage Vp. So what is the waveform? It will look like this. So I am drawing the steady state. Okay, be careful. So this is your Vp minus Vp rather, and you will get this kind of waveform. So it is always negative or equal to 0. So it can touch to this one, so it can go up to minus 2 Vp. Are you convinced? This is a little bit difficult concept. So first capacitor will charge up to plus Vp. Now concept is that if I add one more capacitor and diode, with this, now I have here, okay, this is the input, but I have one more capacitor, but diode in opposite direction. Okay, so you can understand that this potential already I have got this one. So when it is negative, that time this diode will conduct, D2 will conduct for only the first half, 0 to T/4, and that time capacitor will charge up to this some potential. Can you tell me what is the potential across the second capacitor? This capacitor is C1, this capacitor is C2, this is your D1, it is D2. I have said that capacitor C1 will have the potential up to Vp, capacitor C2 will charge up to maximum potential. So what is the maximum potential at this figure? Okay, anyone can tell me? Okay, yes, it will be 2 Vp because this maximum potential is 2 Vp, so it will go up to 2 Vp. So first capacitor will have the charge and potential is plus Vp, but second capacitor is having double voltage minus 2 Vp actually. So it is called voltage doubler circuit. Double voltage you will get it. Okay, and you can find out total output voltage here as well. Okay, what is the output voltage at this end if I consider? So this input voltage is Vi minus Vp plus 2 Vp. No, so this output voltage I can write, or I can write V02, that is your input voltage is Vp sin omega t minus Vp plus 2 Vp. Okay, actually, so Vp sin omega t plus Vp, that's all. Okay, now what is the question? The question was here only, that will not change. So this potential will not change. So here V naught t will remain this thing only. But at this end, the potential, okay, this capacitor potential will be this plus, this is minus, it will be 2 Vp, means 2 volt. But across the diode, this potential, that you can calculate. Okay, that will be your cos omega t minus. So I hope you have got the point. So which one is the answer? The option A, B, C, D, which one is correct? Anyone please? What is the correct answer? I have discussed everything. No, diode will not conduct. Diode will conduct only for one time. Okay, in Clampard circuit, this is the concept. The diode will remain off. That's how we'll get steady state. That will not be conducting. Okay, only for one time it will conduct. You can check this thing. The diode D1, D2 both will be open. Okay, accordingly we will get the voltage. So capacitor will retain their charge. That charge capacitor C1 will retain the maximum Vp, but capacitor C2 will retain 2 Vp. Take proper direction. Okay, and you can see that both the diode will be off forever. Okay, so across D1 the potential will be the input voltage minus Vp. So in this case this capacitor voltage C1 will be 1 volt, thus the Vt will be cos omega t minus 1. That's simple. So answer A is correct, cos omega t minus 1. And if we ask that what is the potential across the D2, then we can consider one loop equations. So you can consider the Vd, you can consider Vd2, you can consider. So Vi plus minus 1 minus Vd2 plus 2 equals to 0. That bigger loop you can consider this loop, and you can calculate Vd2. But keep in mind that Vd2 diode is off. Okay, I hope answer A is correct and you are convinced. This is called Clampard circuit. So for Clampard circuit I am saying again and again, just understand how much voltage capacitor will get. First capacitor will get up to peak voltage, second capacitor will get up to twice of the peak voltage. Okay, that's all. And then you can see that capacitor will retain the charge and you can find out the potentials. Okay, now let us consider the next problem. Now it is similar problem. Can you please solve these things and let me know the answer? Okay, please solve it quickly. So again we have one diode and capacitor combination. So it is a Clampard circuit. Capacitor voltage will attain certain charge, thus it will get voltage. You need to find out the voltage. So here output voltage, it is asked that is across voltage across the capacitor. So it is very easy. Yes, because you are absolutely correct. It is 650 volt. So others, do you agree? So how to find this voltage across capacitor? It's very simple, as you discussed earlier. So what is the potential across this? So remember, it is given RMS. Be careful here. The RMS is given. So if input voltage is Vp sin omega t, this is the peak voltage, the RMS, VI RMS will be Vp, you know that, Vp by root 2. And that value is given here 230 volt. Okay, the RMS value is given this one. So from here we need to calculate the peak voltage. Peak voltage is 230 times root 2. Okay. So this is the peak voltage, input peak voltage. Now what is the voltage across capacitor C1? Can you tell me? Anyone? So better that I should consider this diode is on this side. So this is positive and this is negative. That time it will attain this kind of potential. In the capacitor, right side is positive, left side is negative. It is called positive clamped circuit. Okay. So what is the potential across C1? It is same as Vp that I have discussed. The potential across C1 will be the peak voltage. And second capacitor, how it will go through? This side. So this is plus and this is minus. And that voltage will be 2 times Vp. Okay, that's simple. So capacitor voltage will be 2 times Vp, and Vp, you know this thing, 230 multiplied by root 2. So what is the V0? V0 is now simple, 2 times, and Vp is your 230 multiplied by root 2. And it is coming around 650 point, like that, 44, I think he is correct. Is it fine? Very simple problem. It won't take too much time. In a clamped circuit, first capacitor will get the potential maximum Vp. Second capacitor will get twice Vp. Okay, polarity you can check with respect to diode. When diode is on, which side current is flowing, accordingly capacitor will charge up. Okay, so first one is this side current is flowing, that's how I have considered this is plus, this is minus. And second time this diode is conducting here, so this is plus, this is minus, and value will be 2 Vp, that's all. Yes, so first capacitor will be only potential 230 times root 2 Vp, that is the first capacitor volt potential. First capacitor is 325.22. Is it the half of that thing? No. How you have got 325? Yes, it is half of this thing. Yes, exactly. This is only Vp. You are correct, because the first capacitor will have only Vp, means 325.22. And second capacitor will have the potential twice of that, 650.44. Okay? Any doubt, please? Fine. Okay. This is the next problem. Can you solve this problem? Okay. Now here the circuit is given. Input voltage is pi sine of 100 pi t. We have 3 diodes D1, D2, D3, and it is said that all the diodes are ideal. And we have 2 resistors R and R. One is series with the circuit and other one is across D3. Now question is the DC component of V1. V1 is the potential across the first resistance R, and second one the DC component for this V2. Yes, option B looks correct, but it is really challenging concept. Okay, so how to analyze this one? How to analyze these things, everything? Okay, it's really difficult. So first we need to understand which diode is on, which diode is off, and what time. So I have some configuration. No, this thing is there. So can we consider this thing that when, suppose I will draw here only. This is your time t. This is the input voltage. And maximum peak voltage is pi. It is sin omega t, pi and minus pi. Now in positive half, would you please tell me which diode is on? In positive half, up to 0 to t by 2. And this is your t by 4. Sorry, t. Good. So first half cycle, which diode is on? Please let me know. You may discuss with me. No? So 0 to t by 2, which diode is on? Anybody please? Are you following me? Okay. Anybody can please tell me, in the positive half, in this region, which diode is on or diodes are on? Only D1, because each positive diode current, the current will flow like this, and this side, this kind of current left to right, only D1 will allow. So it is fine. So this is not. Okay. So here only D1 is on. Good. Shivam, it is good thing that D1 is on for first half cycle and second half cycle, what will happen? That time current could be opposite side, no? So if I reverse this thing in the for negative half, this part, current should be like this, and that current will be supported by this D2 as well as D3. Means for negative half, both the diode D2 and D3, they are on. Am I correct? First half only D1 is on, second half D2 and D3 both are on. Good. So you can notice that D1, D2, they are connected parallelly and they are ideal. At least one diode is working. Okay. First half D1 is on, second half D2 is on. So it is short circuit. So no need to take care. This element is shorted always. Right? That we will consider, and D3 is on only for second half. Now we need to consider the waveform. So what is the waveform? So can I redraw the circuit? Please try to understand this one. This is your R1 and this is the input signal, and I have said that this diode combination, parallel combination, it is always shorted for both positive and negative. Okay. So now if I consider for positive cycle, positive half, and I will redraw this one for negative half. So positive half, this is off, D3 is off, so this is off, this is also R. This potential is V1, this potential is V2. Okay, and for negative half, what is this? This is the resistance, this is the AC voltage, this is again shorted, but this time the V2 is also working, it is shorted. So this resistance will have no effect, and this one is shorted. So this is your R. So this potential is V1 and this potential is V2. Right? Okay. Yes, that is the thing. The first two diodes, they are connected parallelly. It is given that in the connection. So remember, one diode is always on, thus it is short circuited, no matter positive and negative half. But D3 will be on only for negative half, and it is off for these things. So now can we draw the voltage? So remember, this is the input voltage. So first half and second half, this is your T by 2 and this is your T. So what is the potential V1 and V2? This is, remember, this is your pi sine omega t. So those resistances are same, so they are equally divided. So in the first half, both will have, so I am drawing two separately. So this is your for V1 and this is for V2. Okay, up to T by 2, and this is a capital T. Right? Now as for first half, it is equally divided and both are positive half. So I will get both this kind of thing. Now what is the peak voltage? Peak voltage was given pi, so it is now pi by 2. Is it okay? This is also pi by 2. Is it clear to all of you? The first half D3 is off, that's how this circuit is working. There is a potential divider circuit, R1 R2, here both are same, so equally divided. So total amplitude was pi, so each one will get pi by 2. Okay. Now second one, negative half. What is happening? It is sure that V2 will be 0. Right? V2 is 0. But what about V1? What is the V1? V1 is simply the input voltage. What was the input voltage? Same input voltage will develop across this V. Okay? Is it correct? So input voltage is pi and negative half. So again I will get same negative half, but this time this peak value is pi, minus pi. Are you convinced? Is it okay? So this is for one time period and it will repeat every time. So you will get this kind of waveform in V1 and V2. Is it fine to everybody? Okay. Is it difficult to understand? Please make comment below so that I can explain in better way. Have you got the concept or I should repeat it? Anyone please? Shivam, it is fine? Good. So now next task is to find out average value. So what is the average value? Average value will be for this one. It could be here. It is a half wave rectifier. It simply B2 is nothing but half wave rectifier output. In half wave rectifier, what is the average? So V2 average will be simply its amplitude by pi. I think you know that, BP by pi. This is the average value for half wave rectifier. That you can use it. And in this case, what is VP? VP is your pi by 2. So as it is pi by 2 upon pi, so it is only 0.5. So average value for V2 is 0.5. Okay. Now what is the average value for V1? How to calculate? So if I consider one half at a time, it will be easier for you. So this, if I consider this positive half, for this one I can have one average value. For this one I can have another average value. For this one. Okay. So this average value is pi by 2 by pi, means 0.5, again like earlier V2, and this one will be minus pi upon pi is minus 1. Is it okay? So for first half average is 0.5, second half average is minus 1. Okay. Now we need to take average of these two. just I can add these two, that's all, not average, because already I have taken over the 2 pi. Okay, I'll just combine these two. So this plus this, so 0.5 minus 1, it will become, so this V1 average will be 0.5 plus minus 1 equals to minus 0.5 volt. This is really difficult problem, it's not easy one, and because you have solved it very quickly, fantastic. So your option B is correct. It is given minus 0.5 volt and this plus 0.5 volt. So average value for V1 is more negative because first half it is getting half only, but second half, negative half, it is getting full. So average will be negative. But for V2 it is getting only positive half, so its average is positive. That's simple. So with the logic you can find out that which one could be the answer. Okay, it's fine. Any question please? Now next question, this one. So can you solve this problem? The op-amp with diode. Okay, one diode is connected from output to negative terminal, inverted terminal, and then one load is connected R in the output side, and input is connected to non-inverting terminal. What is the corresponding output? Input-output relation. Can you find input-output relation? So the 4 choices are given, A, B, C, D, the relation with input and output voltage. Anyone can solve? It's okay because I hope you will get the video later on. So can you solve anyone please? Which one could be the answer? Can you guess? Try to make comment so that I can understand you are following me. So let me explain this circuit. Now when Vin is positive, what is happening? Okay, I'll assume that initially output is 0, but nothing is there. So whenever Vin is positive, we can expect that, so this gap, I am assuming that it is positive. Okay, if it is really positive, right? Somehow for some reason it is positive. And then what is the output? Suppose initially diode was not there, diode is not conducting anything. Then what will happen? the potential will be plus VSS. Okay, so in that case, this output, this op amp output V01 I am writing. So V01 actual op amp output is about plus VSS, and that is very high. If diode is not there, okay, is it fine? But when diode will be there, if diode is absent, remember, diode is not there. So you can see that when diode will be there with this configuration, that time obviously this diode will be on, the current can flow. And when diode will be there, current will be flowing, circuit is closed. And if circuit is closed, there is a negative feedback. And negative feedback, this circuit will behave as a voltage buffer circuit, because this side is directly connected here. No? So if negative feedback is there, this potential and this potential will become same. So V naught will be equals to V in when diode is on, and diode will be on if V in is positive. If V in is positive, we are supposed to get very high potential to the output of the op amp, and that will make the diode on. And as diode is on, circuit is closed, a negative feedback. In that case, now it is readjusted, V in and V out will be same potential. So this, because of negative feedback, so output is same as V in, but diode is conducting. So actually this potential will be, it's not VSS because it's not open loop, it is a closed loop. This value will be, so if it is not the ideal one, it's a practical diode. Suppose this is practical diode, V naught is V in, so at this point it will be this V in minus 0.7 or plus 0.7, right? Am I correct? Is it fine? So what you can see that even if we can use practical diode, this output voltage is exactly same as V in for positive half, but for negative half we can expect that this potential will be minus VSS and diode will be off, and diode is off means disconnected, there is no more connection at all. Okay, so output this side you won't get any current, no current will be there, so output will be 0. So when V in, what I have said that, one thing, okay, now you can see this op amp, I am considering this is positive, this is negative. Okay, here Vi is applied, there one diode is connected, and this is connected here, and then one load is connected. Okay, so when Vi is positive, this is the first case, that time what is happening, this output voltage V naught will be same as Vi, because D is on. Okay, is it fine? D is on, because of the negative feedback is completed, and we will get V naught equal to Vi. But second case, when Vi is less than 0, diode is off, disconnected, it's open loop. Open loop means simply it is not there. So this end is connected to this one, so current will be 0 ampere, no current will flow. So potential drop across resistance is 0. So V naught will be 0. And that is due to D is off. So what is the meaning? When this is Vi and this is V naught, when Vi is positive, V naught is same as Vi. It's linear. And when Vi is negative, output is always 0. So this is the curve. It is 0 and right side is linear. Are you convinced? This is the relation between Vi and V naught. Is it okay? So what is the advantage of this circuit? This circuit is called precision rectifier. This is one type of rectifier circuit, because for positive half output is same as input voltage. For negative half it is absolutely 0. It's truncated. Okay, it's clipped off. So only positive half, a positive rectifier circuit, half wave rectifier circuit. So this is nothing but half wave rectifier circuit, but it is called precision rectifier. Why? It is very precise. Even though if you use practical diode, silicon, and its potential is about 0.7 volt, or even if it can have certain resistance also, doesn't matter. The output voltage is same as input voltage for positive half, and negative half it is absolutely 0. So you will get this kind of waveform. But you can see that if I consider some practical diode, like this is one practical diode and then one resistance, it is also one rectifier, but this potential 0.7 volt is lost. So rest will be available here. So this voltage will be Vi minus 0.7. Okay, that is the difference. So always you will get less than input voltage while diode is conducting, if I consider diode is practical one. Okay, but in this case there is no loss. The output voltage is same as Vi. That's how this diode is called sometimes super diode. It is also called super diode configuration. Any doubt please? Are you convinced? Any question? So this is better or perfect half wave rectifier. I can use practical diode, doesn't matter. Op-amp will take care, and I will get full voltage for positive half, and for negative half it is absolutely 0. That's how it is called precision rectifier. So if you are interested, I can continue. Okay, I have few more problems to discuss. I may continue for a few more times, but students are there. Okay. Now this is the next problem. Can you solve this thing? This problem appeared GATE 2021. It's interesting problem. Okay. So can you solve? Can you please let me know what kind of circuit it is? Anyone please? What is the circuit? Can you identify the circuit? The circuit, here we are having 4 diodes and 1 capacitor resistors. What is the circuit? Anyone? So this circuit is nothing but full wave bridge rectifier. Am I correct? It is a full wave bridge rectifier and the capacitor is used as an filter element. Okay, it's RC filter to remove the pulsating component, the ripples. So capacitor will remove little bit the ripples and it is basically one full wave rectifier. I hope it is clear. No? In positive half 2 diodes are on, negative half other 2 diodes are on. That's how total circuit will work. Now here question is that what is the worst case peak inverse voltage seen across any diode? I hope you have certain knowledge about peak inverse voltage. So this is the voltage appeared across one diode when the diode is not working, when diode is off. When one diode is off, some voltage will develop across the diode, that is reverse bias voltage or inverse voltage. I will call here inverse means reverse bias voltage. And what is the maximum voltage when diode is off? That is the important thing. In bridge rectifier, full wave bridge rectifier, the peak inverse voltage is same as the peak voltage of the input voltage. Okay, I think it is known to you. And but for center tap full wave rectifier, we are using 2 diode. In that case, the peak inverse voltage, okay, that will be twice of Vp, the peak voltage. So that you should keep in mind for full wave rectifier. So why it is so? So if you want to understand why it is so, suppose if I consider the positive half, this is positive half, so the current is coming here, so this diode is not on, this current will go to this side, okay, then again it can't go this side, it can go this side, okay, then it will go through this filter circuit, then again it will come here. So but this time it will go through this one and it will come back here. Okay, so this is the path for forward potential, positive half. So in this case, suppose this diode is off, obviously this is on, this is on, this is off, and this is also off for positive half. Now when it is off, what is the potential across this point? That we are interested. So if this potential peak voltage is Vp, so that one time it will attain peak voltage Vp, that time. So if it is ideal, it is shorted. Okay. Now what can I do? I can take one loop, any one loop. So it's very simply this to this end. So you can see this is shorted. This diode is on, it is shorted. So this end to this end potential is again Vp. Can you see this one? Because this end potential is Vp, this to this means this to this, exactly same. means across this diode potential will be plus Vp. So Vp will develop across this diode because now it is in off condition, but peak voltage is Vp. Thus peak inverse voltage PIV is simply Vp. So we need to find out Vp, peak voltage, that is important. So it's now RMS value is given. So can you find out first RMS value? 230 volt plus minus 20. So maximum peak I want to consider. So I will consider plus sign, not minus sign. Okay. So 230 volts plus 20%. How much it is? So 230 plus 230 of 20%. I think it is 46. So it is 230 plus 46. It could be 276. Remember, this is the VI RMS. Yes, it is 260.22 that you are claiming. Is it that much only? Why it is 260? Now first we need to include this thing, 20%. 20% extra is there. So 230 plus 20% is 276. So this is your 276. Now I need to consider Vp. This is given RMS. So peak value will be more, multiplied by root 2. Is it fine? Can you calculate this one? 276 square root 2. What is the value? That value will be a peak voltage of the input voltage. One time you will get it when it is positive 20%. And I think that value could be how much? 390. Okay, it is 390.32. Is fine. That is peak voltage, and that is nothing but peak inverse voltage. So peak inverse voltage is 390.32 volt. Because in full wave bridge rectifier, where 4 diodes are used, peak inverse voltage is simply Vp. But center tap full wave rectifier, the peak inverse voltage is double of that, 2 Vp. That's how this bridge rectifier is preferred, because its inverse voltage is less, half of that. Okay, because if PIB is little, then it is fine, no? Otherwise there is a chance that diode will burn out. Will get burn out, okay, right? Any question please? No? Can you solve this problem? I think I can take one more problem. Can you please try? What is saying? It is saying that input voltage is pulse train, impulse train. Okay. And then one capacitor is given in series, and then parallelly 500 kilo ohm and one diode. Diode is considered as ideal one, right? Now we need to understand in the voltage V0, the question is difference between maximum voltage and minimum voltage. These two only you need to identify. What is the maximum voltage V0 and what is the minimum voltage V0, and that difference we need to compute. So can you draw the waveform of this circuit? And it is given that the on time for this pulse is only 1 millisecond. It is 1 millisecond, and off time is 1 microsecond. Right? So it is almost on all time. Right? But okay, for that duration 1 microsecond it will be off. So can you draw these things? So can I explain this circuit? It's a really interesting problem. We have one capacitor here, we have one resistance and one diode. Okay, and here this is a potential and we have one pulse train like this. This is a capacitor C, this is one R, and this is a diode D. Now you consider this thing carefully. This is the time T, this is the on time, and this is the off time. Suppose I am considering this is 1 millisecond and this much only 1 microsecond. Then again it is on. It's like this. This is 1 millisecond, and that gap is 1 microsecond. Okay, and this amplitude is 10 volt. So this kind of input voltage is given. Okay, now when 10 volt is applied, so what will happen? The capacitor will charge up, diode will be on, and it will charge up in no time, because this diode is ideal, so current will flow through this side. Resistor will have no effect at all. Okay, so capacitor voltage, if I want to draw the capacitor voltage rather than this output voltage, so output voltage we will draw later. We want to find out capacitor voltage Vc. So capacitor is charging and instantly it will charge up to 10 volt, right? So can I say that capacitor voltage will be like this, 10 volt, and when the input is absent, now for this 1 microsecond input is absent. So can you see this? When it is off, input is absent, input equals to 0. Okay, for this 1 microsecond, what is happening? I have one capacitor, input is not there, this is one resistance, so this capacitor will try to discharge in this path and diode will be open, reverse biased, right, because current cannot flow in the opposite. So now this capacitor will try to discharge from 10 volt, so it will discharge with the time constant R into C. So time is very little, so it will decay very little, this much only. Is it okay? And then again when input is coming, again it will charge up to this thing, again it will be like this, so like this. So this will be the output voltage Vc, the voltage across the capacitor Vc. Now can you draw the V naught? So what is V naught? Can you see the V naught? This is interesting. So V naught is actually input voltage minus Vc. We need to subtract. So can you tell me what is the output voltage during first 1 millisecond? Anyone please? What is the output voltage across the Vd during first 1 millisecond? Anyone please? Okay. Is simply difference between input minus capacitor voltage. So what is that? Anyone? Can you please comment on? No? No one is there? So input is 10 volt. Vc is also 10 volt. So 10 minus 10 is absolutely 0. So first 1 millisecond the output is, because diode is conducting. If diode is conducting, that voltage is 0. Okay, that's simple. So this output voltage is a green color, that will be 0. Now beyond 1 millisecond, what is happening? Input is absent, is 0, no input, only Vc is there. So minus Vc. So you will get suddenly negative 0 minus Vc. Vc was 10. So it is suddenly it is becoming 10 or something. Okay, I think it is 10. No, it is becoming minus 10 volt. Then capacitor is reducing gradually. Okay, because it is minus Vc, it will be also like this. And when again next time diode will conduct, it will come to 0. It will be 0. So this is the waveform for the output. This is for output voltage V naught across the diode. Are you convinced? It's a really interesting problem. Now if anybody is there, can you please now find the solution? What is the difference between maximum value and minimum value of the output voltage? What is the maximum value? So the output is V naught, that is shown in green, and it will vary from 0 volt to minus 10 volt. So this voltage is not required to calculate. The maximum voltage is 0, minimum voltage is minus 10. So gap between these two is 0 minus 10 is your 10 volt. And that is the answer. Is it okay? So the question was, what is the difference between maximum voltage minus minimum voltage? And this one is 10 volt here. Okay, answer is 10. Good. Generally you are right. It is maximum is 0 and minimum is minus 10. So difference is 10. That's all. Now I will give you two problems that you will solve and share your answer in the comment section, comment below. Okay, read this problem carefully. I have discussed lots of problem. I think around 9 or 10 problem I have discussed. You have got the idea? Now can you solve this problem? This is one diode is one given practical diode. When it is on, it is 0.7 volt, and when it is reverse biased, it is 0 only. Okay. So this is a circuit. Input B in is mentioned. So now we need to understand dV out by dV in. Okay, and ratio of the minimum to maximum small signal voltage gain. So we need to find out when diode is on, what is the relation between input and output. You will get certain relation, input and output. Then take dV out by dV in. You will get one ratio. So one relation, obviously you will get it. So find out dV out by dV in. And when diode is off, again you will find another relation between V naught, V out and V in. Then again find out the derivative of dV out by dV in. You will get another value. Okay, and then compare these two, which one is larger, which one is smaller. So minimum to maximum, this ratio you need to find out. It's really challenging problem. It appeared GATE 2022. Please solve it neatly and share your answer in the comment section below. And if you can't solve it, please let me know. I'll make dedicated video for that. Okay, if you find difficulty to solve this one, please let me know in the comment section. It's a bit challenging, but I am leaving it for you. Another problem, I am leaving it. This one. This is another difficult problem. It appeared GATE ECE 2016. So we have one diode, one capacitor, and one current source. This current source is actually the load current. And load current, they have said that it is a constant current source. Instead of resistance, if I provide one constant current source, it is much easier, because capacitor will charge up because of that in opposite side. Actually, if resistance is there, capacitor will discharge. The same thing is happening with this current source. Capacitor will discharge in opposite direction. Okay, means charge up in opposite direction means discharge. So for first half, capacitor will charge up. Okay, and then later on, after certain time, capacitor will try to discharge. Again, after some times it will start charging. So basically here it is a half wave rectifier along with one capacitor filter, the I filters. Okay. Now question is, how much ripple you are getting? So this potential gap, this U, can you find out this U value? And one hint I am giving you, while diode is off, when diode is on, that time it is fully charging to this path only, and instantly discharging. It is following the input potential. But when diode is off, that time this current source is working and capacitor will charge in opposite direction, means little bit it is discharging. So C dV dt will be, so this is the current here, C dV dt, that will be your, this current given 1 means it is minus 1. So from here you can calculate the V naught. So this is very easy equation, C dV dt equals to minus 1. So you can find out relation for V naught. I think you can get it, minus 1 upon C times T plus the constant C1, one integration constant, and integration constant you can find out considering at t equal to 0 the initial voltage for capacitor. Okay, so this is really challenging problem. You solve it and find the answer. I hope it will be difficult for you. So let me know if you can find it out. If you can't solve it, then also let me know. I'll solve it for you. Okay. So if this video is useful to all of you, just press one like button. That's all. Okay. So thank you very much for all of you. Right? And we'll meet again in some other videos. Please let me know in the comment section if you have any doubt. So thank you very much. If it is useful, just press like button please. Okay? Thank you.